Welcome, everyone. I'm Mary Conley-Eggert, and I'm with Global Waterworks. We're partners to the World Water Action Forum for about 4 years now, and every first Friday, we focus on an area of interest and have what we call a soul search, bringing forward some of the experts and also the technologies and the potential users within India and within Africa now and around the globe to look at how we can apply these technologies and accelerate solutions to the global water crisis. We're delighted to have you here with us. We know many of you are new, and we welcome your introductions of yourselves in the chat. You can put in your name and your email so that we do capture everyone's interest. And please also use the chat for any questions that you have. We'll be monitoring those during our call. It's a 90-minute session, and we're going to have our presenters join us first because we want to have you have the benefit of having some context and understanding what their applications are. But before we do, I'd just like to mention we do have World Toilet Day coming up here November 19th. And that is the reason for our focus today, because there are a lot of people who care about toilets. In fact, about 3 or 4 times a day, I think each one of us do, and maybe more. But what's important is that this conversation matters because you may have a toilet, but 3.6 billion people, according to WHO and UNICEF, do not have safely managed sanitation services. That means they are either exposing themselves to harm or illness or defecating in the open and exposing our waters to contamination. And there are 400,000 deaths annually. And even in the developed world, toilets that are unmanaged and unmonitored contribute the #1 source of in-building water loss, a huge issue in areas where there's water scarcity. So today's speakers will talk about both the need for the developed world and the developing world and the solutions that you can be aware of and start to spread the word on, but also that you can help build in some places. And we are thankful to a wonderful innovator who you can meet, the #2 man who actually implemented and introduced the World Toilet Organization 27 years ago when he said, what can I do now that I've had an accomplished career? I want to actually help people. What is the biggest need? And he discovered toilets and sanitation to be that need. And amazingly, you'll see him here looking like 007 because loo, the British word for toilet turned upside down, is actually 007. And there are many other fun aspects to toilets that he shares in this post that I will put into our community here. But it is part of the Global Waterworks platform where you can find solutions to your water challenges, and you can also solutions and help us more quickly address the needs of our world. So back to the Toilets for Peace and the opportunity to address them. We have Chandra from Watsan. He's the CEO, founder, award-winning innovator on drinking water solutions, but also has been innovating on toilet and sanitation solutions. And I'm going to stop sharing and ask Ankur to share a preview video to what he's about to tell us. And as he brings that up, I also just want to preview our second speaker, Susan Springsteen, who's joining us from Pennsylvania in the United States and just won the Indian Innovation Award and will be flown by the Thai group to Bangalore next month. So if you have interest in toilets or water loss in multi-unit apartments or schools, universities, hotels, she will detail what her technology is doing and why it's winning so many awards.
A big challenge in sanitation is building and maintaining toilets in villages because of limited resources, limited manpower, and high transportation costs. But this engineer saw these problems as an opportunity to create new solutions. He set up Watsan to tackle last-mile challenges in water and sanitation through technology.
A decade ago, I visited more than 2,000 villages across Tamil Nadu, where I wanted to photo document the dilapidated temples. wherein I found the problem of water and sanitation lacking. So this made me start Watson, as the name indicates, water and sanitation.
For sanitation, they focus on the problem of constructing toilets without depleting river sand or a lot of water. Chandrasekharan then started looking for a better raw material. Huge amounts of fiberglass from the windmill industry are discarded, which then end up in landfills. Sadly, there are no takers for this. They upskill this waste fiberglass as building material for their toilets. Tiruturaipulli is one village in Tamil Nadu where Watson's toilets have been constructed, where they trained a group of women to do so.
நாங்க ஒரு வாரம் வந்து ட்ரைனிங் எடுத்துக்கிட்டோம். ரோகிணி இது மாதிரி வெட்டணும், ரேஷன் இந்த அளவுக்கு கலக்கணும், இந்த அளவுக்கு கோட்டிங் அடிக்கணும் எல்லாம் சொல்லி கொடுத்தாங்க. அப்ப 40 பீஸ் செய்யணும்னு சொல்லி கொடுத்தாங்க. அந்த 40 பீஸ் நாங்களே செஞ்சு முடிச்சிட்டோம். இதனால எங்க மகளிர்களுக்கு ரொம்ப உதவியா இருந்தது. இப்போ நாங்களே பண்ணுவோம். அவ்வளவு ஒரு ஈஸியா இருக்கு.
Chandrasekharan and his team have made it possible for the people in an area to construct toilets themselves by providing affordable molds and raw materials. But sanitation is just one pillar of public health. There are all kinds of challenges when it comes to drinking water in the country. In the Northeast, there's arsenic in the water, which causes cancer. In Rajasthan, Telangana, and parts of Karnataka, there's fluoride in the water, which leads to fluorosis and bone diseases. It's not that there isn't enough water, but there isn't enough clean drinking water. To tackle this, they developed a water purifier that does not need electricity to run, and so it can be used anywhere. The filtering component is a special nano clay candle with micropores to remove microbes, heavy metals, and turbid water. The most important factor in making the clay candles is the selection of ingredients such as clay and sawdust. A candle goes through a 13-day cycle of mixing, soaking, drying, and burning before it is taken out of the kiln. The candles are then bundled and shipped to the Chennai office, where it is assembled with an antibacterial cementing material into the plastic holder to fit into the filter. The purifiers are used by the Border Security Force and during natural disasters. For their contribution to water and sanitation in India, Chandrasekharan has won several awards. But he is not done yet.
So we're very excited to have Chandra here to share an update on what they're doing with the sanitation in the villages across India and elsewhere. And Chandra, I will turn it over to you.
Yeah, good evening. Thanks for the video run here. This was some 6-7 years ago. Now we have crossed close to 120 toilets and more than 500,000 rural households where we are given the water purifiers. Thank you.
Yes, and Chandra, I don't know if you want to share any slides related to your efforts, but maybe you could just answer some questions, if not, on the process and how we all get involved.
Yeah, actually, as the video shows, it was an accidental discovery or maybe a realization that when I went to photo document the temples around the villages in India, which are again in big numbers, like 125,000 temples are lying in ruins, which are aged some 2,000 years to 500 years old, with all the beautiful inscriptions and sculptures all lying around uncared. And those are being robbed away and they are being sold in the name of the artifacts, smuggled basically and given to these art collectors and things like that for crores and crores of money. So to create that awareness, we started photo documenting and giving it to the public authority, the ASI or the National Monuments Authority. In this journey, what was revealed to me by God himself was the need of water and sanitation. So that is why, in fact, I took up sanitation as the first agenda, because getting cement to the last mile and getting good water without salinity, without hardness, and also getting sand. Sand is again natural resource which is being robbed off from the riverbeds and other things illicitly, and only politicians do have access to the availability of sand. So it's a huge racket going on. So I wanted to do away with all these things and make something environmental friendly. That is why, as a plastic engineer, I thought the glass fiber waste which are dumped in the fiberglass industry are an astounding 3,000 tons a month. That is a huge volume of glass fibers. Basically, these big windmill blade manufacturers buy large acres of land just to bury this glass fiber and forget. So in that region, no plant or no flora, fauna will exist. So that is another ill thing they are doing for the ground as well as the environment. So I thought, why not take out those materials which are actually bulletproof? If you make it beyond 3 mm, it becomes a bulletproof strong structure, glass fibers. So I thought, why can't we perish it for just making toilets which are static? Not even the wind load, what is affecting the windmill blade or anything is there in this. In fact, the video shows Tirutharaipundi, which is close to the seashore. In spite of huge wind and whatnot, whether high weather or salinity, these structures are lightweight. You can see women just carrying one wall, and these are all cubicles made with separate joints. Got to just drill a hole and fix a self-drilling screw, and that's it. The toilet is ready. So, and again, if you look into the need of the country, if you look at, say, the rural population is almost 73% of the Indian 1.3 billion crore populace. It means the toilets have not been even given to 50% of the rural population. So we need to make, you cannot waste the time on constructing a toilet. Toilet takes at least 6 or 7 days to construct. You don't get a quality mason there. Even if you get cement, water and sand, you don't know whether the ratio of the mix is correct, RCC is correct. Even if it is done, you don't know whether the local people are cheating out by not giving quality cement. So a lot of if and buts in the whole thing. Here what is happening, you have given a pre-measured glass fiber and the resin, everything, which cannot be underused or overused. So they can use only those set of liquids and resins for making the glass fiber. And the beauty is you don't need big machinery with electricity. It all cures in sunlight. India is having very good sunlight beyond 35 degrees. So easily it will cure in 1 day's time. So we say don't construct toilet, you manufacture toilets. That should be the speed so that you can fill the gap of the demand and the supply. That is why we did this. But unfortunately, the typical governmental agencies have a lot of frills or bottlenecks in approving a product or even resourcing these glass fibers from the big windmills like Suzlon and Gamesan, bringing it to the last mile creates a lot of problems. The pollution control board comes in between. They say, why do you take? Where do you take? What are you doing with it? Then we have to answer so many red tapeism. So I really got, in fact, as you see in the video, we have even upskilled the local women who don't have a job. Imagine they can make one toilet today. They can convert the whole village into a open defecation free village. Even though on paper it is shown by the government, I seldom doubt any of these villages are completely out of this open defecation because of the lack of raw material, lack of understanding alternative materials, and the transparency in approving new innovations and things like that. So that is where we stand. That is why it is a too low a number. 200 is nothing when compared to the need. But as an engineer, what best I could do? I can only innovate and keep on trying. In fact, these 200 also were given by corporate social responsibility of big companies who understand me and my innovation and the product. So they choose the village. They have an access. Let us say a fertilizer company selling fertilizer in that village. So they wanted to do something back for the water and sanitation issues there. And again, another misrepresentation is the instant hitting of the toilets with acid. All these big companies are putting it in a bottle and hitting it with superstars advertising for it. But that is totally unscientific. You hit the toilet with the acid, the anaerobic bacteria inside the toilet gets killed instantly. Thereby, no digestion can happen. No fecal matter can be digested by the millions and trillions of anaerobic bacteria. And the whole thing remains as shit and urine. It goes to the STP, churned out again by unwanted technology. Ravalji will be able to explain it much better than me. So unscientific things are being repeatedly told by these big MNCs and pushed through your neck and body by things like this. So we don't know where we stand, but our effort keeps going on. This is the short and long story of what Watson has done so far.
It's a beautiful story. Yeah. And I'm going to ask Ravalji to comment just on the biological aspect of it in a moment. I just want to acknowledge a lot of people have asked about our political system here. And the #2 man in toilets said he was managed to get Modi elected or supported his efforts by offering a toilet movement and the addressing of the sanitation issues in India. And so perhaps toilets hold an answer beyond just our water treatment for politicians and those who want to gain favor with their citizens. But thank you so much, Chandra, for your innovation. I'm putting your link to the details in your website here in the group. But Ravalji, could you comment? Because we do face this challenge here also in the US with septic systems and the toxicity of what's put into those septic systems to treat or annihilate waste and bacteria. What about the biological approach that Chandra has taken? If you could speak to that and how that would help our environment overall.
This is a wonderful, wonderful work Chandraji has done. And in one word, he has covered the whole secret of sewage science. He used the word clay. The clay is a different regime of nature. Nature has two regimes. One is photon dependent, which is governed by the photon energy coming from the sun. But the second energy regime that holds the secret of homeostasis, planet homeostasis, that comes from photon independent energy regime, which is geochemical energy. The life originated at the bottom of Pacific. It was not the sunlight, not the solar energy. It was the geochemistry that set the chemical machinery into the motion. And the same photon independent mechanism is working in our colon. Colon energy mechanism is not solar light dependent area. So if the moment he used the word clay, and of course, Dr. Neeta Sahai, she did her PhD on geochemistry from California. You can see her YouTube lecture. Phenomenal. The point is, conventional sewage is focused on the pipe and diameter, on KLD and MLD and MGD, and clariflocculator and horsepower, and my good God, bless you. Chandraji, wonderful. I would like to discuss with you clay at length, and I'll send you some of the YouTubes. Wonderful. Thank you very much. But it is photon independent energy regime that holds the secret of climate stability. Thank you.
Niranjan, thank you.
Chandra, always a pleasure to hear you talking. Great. Just a thought occurred in my mind. You have given examples of waste to wealth. You have talked about simple engineering as opposed to complicated engineering. Now, my question to you, you must be aware of Sulabh, which has been in this domain for a very long time. Is there a possibility for you to network with them so that they can also accept this concept and scale it up, because they have the bandwidth of scaling up? So just a thought which occurred to my mind.
Yeah, sure, sir. Actually, we are waiting for people to take it up. In fact, this video is 6 years old. And sorry to say, I got a national award for this innovation 10 years ago.
Oh my God.
Where have I left? See, we went to all the ministries, concerned ministries down the line to get the approval done. They almost questioned me for 6 full hours and wanted me to prove and all those stuff. Finally, they landed up with a very fantastic question. Kitna sasta padega? How cheap can you make a product? I don't understand what is a affordable product and cheap product. There's a huge differentiation in the whole aspect of using, and the climate change, what we are going to create. by installing too many RCC toilets. The carbon emission, which itself is going to kill the environment, rather in the reverse, we are using the waste which are dumped, which is again a solid waste issue which cannot be managed, and trying to convert it with natural energy into a beautiful product, which could even be taken up in batches. Like you can make all the 3 walls separately, the roof separately, the bottom separately. Even in high terrain like hilly regions, you can carry it very easily. You saw the video, just 4 women are taking and lifting and fixing it, but still it is bulletproof and strong enough to take any wind load or anything like that. So they are not at all focusing on the innovation part. I have failed a lot of time going and explaining to people and meeting ministries and stuff like that, because that is not my cup of tea. I am an innovator and I am, see, my own places where I have done water and sanitation, we say this, then we use vinegar and neem oil for the cleaning part. No acids are used. The STPs are easily treated within 7 to 8 days by anaerobic bacteria inside the soil. In fact, we have developed cubicles also. If you give me an opportunity, I am ready to work with you at any level, train anybody and make sure that this can be proliferated to any number of people, sir.
But Narinjan, thank you so much for chiming in, because this is actually this is the reason WOW Global exists and can help, because we connect the whole water ecosystem. You know, the CSR, the corporate people, the fundraisers, the government, and the citizens, and the technologists like Chandra. So so thank you so much. And
Gary, you are sitting in a country with so many foundations with billions of dollars. Can you send 0.005% of that to Chandrasekhar?
I know.
Yes, I'll use your pitch. Thanks. Okay. And I'm thrilled, as I mentioned, for those who didn't hear, Susan Springsteen is here to join us next. On the other side of the toilet, the advanced water monitoring of Western toilets, which happen to be the contributor of the #1 source of in-building water loss. A big challenge. The amount of 2 cars, actually, the water loss of 1 toilet could contribute to 2 cars, the weight of 2 cars moving inside and outside of a building in 1 day. And fortunately, Susan's innovation has enabled and others to put a stop to those leaks, to identify them in advance. And Susan has a presentation to share, but she will also be in Bangalore here next month in December. For those of you who want to meet her, the Innovation Network is sending her there because she won the award, the best pitch of technologies at a recent presentation. So I'm thrilled to have a voice of another woman here talking about water and waste.
Okay, well, hello, everyone. It's morning over here. I'm still not sure exactly where it is for where you are, but thank you for this opportunity to talk to you all about a device that my company invented. I'm the co-founder and CEO of a company called H2O Connected. We're located in Pennsylvania, outside of Philadelphia in the USA, and we developed the leak alerter technologies, which goes inside a tank toilet and can detect nearly every type of water loss problem that can occur in a tank toilet. So water waste in a tank toilet, we're finding, is really the #1 cause of water waste in a building. The Environmental Protection Agency in the United States has done studies that says that 20% of all of the 300 million tank toilets in the US are leaking at least 50 gallons, that's 200 liters roughly, a day at any one point in time. So it's a big problem. We're finding, because we can monitor toilet leaks, we're finding the problem is actually much worse. We have running toilets when the chain hangs up and the flapper inside the tank is wide open. And if a building is on public water without water pressure, it can waste 7,000 gallons or roughly 26,000 liters of water a day. So just huge numbers. Where you just have smaller leaks from different parts of the toilet that aren't working properly, that can be 50 to 200, 300 gallons a day. The other thing that most people don't know is that a lot of buildings now have, or it's required to have low flow toilets. The problem is a lot of those low flow toilets aren't set at the proper flush rate. And so they're still flushing, even though they can work with a less water, they're still flushing at 3 gallons, 2.5 gallons per flush. So that's wasting water. And then there are overflows, so then you have property damage. And the problem with toilet leaks is that with these tank toilets, there's no water on the floor. So there's no way for someone to really know that the toilet's leaking. It makes different noises when it's not functioning properly, but most people don't understand what that means. There's not a lot of education here around toilets. So, so we wanted to solve that problem. Just to let you know a little bit more, compare it to other water saving products that are out there. A lot of folks try to save water through aerators in the shower and the faucet. And this is all a good comprehensive plan. But to show you the difference, where a faucet aerator can save 9.5 liters, 2.5 gallons per day, or a shower aerator can save even more than that. Toilet leak detection can save exponentially more water. A faucet aerator saving 9.5 liters a day is like providing 45 showers here in the United States. The average shower here is 10 minutes. So aerator is almost 3 times that. A toilet leak detection, if you know your toilet's leaking and you repair it, you can save almost 1,000 liters a day from a toilet leak, or 26,000 liters a day from a running toilet. So just massive amounts of water that are wasted through these tank toilets that have, in the buildings, and nobody knows. So in addition, water also is connected to electricity here. So most of our water is transported and treated using pumps and treatment plants that are powered by electricity. So when you're wasting water, you're wasting electricity as well. And if we can eliminate that water waste so that it doesn't have to be pumped through the system and it doesn't have to be treated, then we can save, and we can take the burden off of the electrical grid and then reduce greenhouse gas emissions. So water really provides that trifecta of sustainability in so many ways. So we developed our system. This is our wireless system. It's called the Leak Alerter Wireless Pro. And this device here goes inside the toilet tank, so it isn't seen by anybody who's using the bathroom. And it uses a smart water height sensor here to monitor the rise and fall of water height. And so it can monitor everything that's going on inside the toilet, whether it's a flush or whether it's a leak. And it sends data we have our own gateway. Usually, for instance, a hotel would need one gateway. They can put this in the maintenance closet. And it's LoRa transmission to the gateway, and then it uses either Wi-Fi or cellular to send the data to the cloud. We send a text message to our customer if it's a really urgent issue, like a running toilet or an overflow. We send work orders once a week for all issues. So maintenance, whoever's fixing the toilets, knows what to fix and where the problems are. And then everything someone needs to know are reported on a dashboard on any internet connected device. So our dashboard will tell our customers what the problem is and what to fix in the toilets, because it could be a flapper, it could be the fill valve, it could be both. Where the location of the problem is, what room or which toilet it is, the severity, how many gallons are they wasting per day, and since the problem started, because that way they can prioritize repairs. Frequency, so how often does this happen, and what's it costing in both gallons per day or liters per day, and money. And then we're also, by next year, we'll have a predictive AI component to it. So we will be able to alert our customers when something's going to go wrong, so they can plan it rather than waiting and being reactive. We can tell them, let them be proactive, so they can fold those, fixing those toilets or replacing those parts into their maintenance plan before they actually waste water. And this is a case study of a hotel outside of Philadelphia, and this is horrifying how much water this hotel was wasting. They have 107 rooms. In the first 30 days, they were wasting almost 84,000 gallons of water through their toilets. 88% of their toilets had at least one water wasting issue. And if they did not have our system, it would have added $16,000 to their water bill over the next 12 months. So they were able to pay for the system in about 8 months out of water and sewer savings. We also have a device for the home. It's currently available on Amazon. It's not wireless and it hangs. This is the sensors go inside the toilet tank. The alert is on the outside of the toilet tank, and it uses a red light, green light approach. When your toilet's flushed, it flashes green if everything's okay. If there's a problem, it flashes red and beeps, and depending on how it flashes and beeps, it'll let you know what component needs to be replaced and what the problem is. So, and this is the team. Wanted to give you a sense of who all's behind this. My partners. This gentleman has been studying tank toilets for 20 years. So he's our resident expert. And so I just wanted to give you a sense of what we were doing. And I'd love to somehow work with you, and because we all want to save water.
Absolutely. And I think having well-maintained toilets, you know, in the Western world and in the developing world is key to that. And I wondered, Susan, if your technology, well, because it monitors, and I have a leak alerter on my toilet, actually at my home, and was going to bring it into demo, but as soon as it got out of the water and was detecting, it started to beep, and so I'd have to navigate the battery. You showed it well, but what is beautiful is the WOW group actually visits multi-unit buildings and helps them with the conservation. So I thank you for that comparison with the aerators versus the toilet savings. And we have a few people, BK Prasad from the toilet industry, from the plumbing industry. BK, if you might be able to comment on this as an application relevant to India and your plumbers. I don't know if you've seen it or had the chance to like this out, but BK, could I ask you for some comments on your thoughts?
Very good evening to you all. Susan, that was a very nice presentation. In fact, when we are approaching net zero by 2050, where we have to save water in a very big way, this is one of the very good inventions. So definitely we can, adapt this technology in a very big manner in India, so that it can be very helpful in net zero. That's like, and also it will help in power saving, as I said. So it also helps it, net zero in power. So these two conditions can be met with these toilets, invention. So if you want any help here through our organization, I can definitely put you across to the right people in Bangalore. You'll be in Bangalore, so I can meet you. I'm from Bangalore, so I can meet you in December. That's right.
Yeah, I told Susan I had the chance to go to India 3 years ago and need to go back very soon. But it's been such a captivating country. The energy, the color with the women in the saris, and the foods, just all the beautiful things happening in Bangalore, one of my favorite cities. So you will have a wonderful time. But Susan, if you could remove your screen, we have the wonderful opportunity now to turn over to Hari Chandra, who understands the group here, and we invite everyone's questions, comments, and I did see 2 questions here for Chandra to start out, but excellent presentations by both of you. And Chandra, a question that was raised by perhaps Hari is what is the arrangement for water for the toilets, and have you found them to be maintained well, clean, and usable?
Yeah, again, it's a very good question. The water space in close to these toilets are also very different. In a low-lying area near a sea, water will be almost close. So you can't have a septic tank going down. Otherwise, the contamination will be very high. Or when there is a flooding, all the material inside the septic tank will start floating. So there are a lot of ways it has to be customized and tailor-made, which we are doing. After deciding in which geography we are going to do. Again, water, if there is a pipeline connectivity, that is the most interesting thing. You can have couplings drilled through the wall of the fiberglass door, and you can easily fit a coupling where a tap can be connected and through pipeline. If not, they carry, there will be a huge tank, open cement tank or anything in which water is stored once in a day by the common supplier, municipality or the panchayat will come and fill water in the whole tank. A community of people who are accessing the toilet, normally we do both, like separately for women and separately for men, so that there should not be any issues on privacy and also the accessibility. Second question Hari asked was the acceptability of these people psychologically going into a toilet, rather they feel free going out in that field. Not so. In fact, women are very, very conscious. In fact, they feel very shame and ashamed and helplessness when it comes to defecating behind the bushes or near a water body or something. That is the reason most of the villages, sad to say, they go after the dusk, in the evening hours when the light is down. They all walk in group with a small lantern and go behind a bush, relieve themselves and come back. In fact, what triggered me to get into toilet was also some sad story like this. Yeah, orphanage near Tamil Nadu Andhra border in Nagari. There was a missionary run orphanage where a girl was stung by a scorpion when she went to defecate herself in the night time with other girls. They didn't notice it. They went back chatting and they all slept. Next day morning, when they went in search of this girl, they saw she was already dead and lying still. So the sister, one of the NGO there called me and asked, sir, you said you are doing something in the toilet. Why don't you do it? So it was just an idea. So to make it immediately, I spent almost 10 to 12 lakhs to make the mold immediately within a week's time and go there and install some 10 toilets free of cost. In fact, this is how I started actually and gave me that confidence. Yes, whatever we can innovate can be of good use. Until date, we have been in good touch with that NGO and they have recommended in more places. It is not the question of the psychological issue or imbalance. If you have a very quality toilet, people obviously come. There was a movie recently 4 or 5 years ago called Joker. What happens? The government has amounts allocated. The local contractor will just put a color door between just before one RCC toilet which has been made and one family picture before that green door. Then another blue door, another family. Another brown door, another family. So same toilet, he'll just change the door, show that he has built that many toilets and cheat the government and make the billing. Finally, the people will not get the toilet. So this is the reality what we are facing. If you go and see in the villages, acceptability is very much there. In fact, discipline is also there when we teach them. Don't use harpic, come in a queue. In fact, there is a key and lock with a bunch of people. We say at this timing somebody should come. At this timing the girls can come sort of. If you arrange it properly and give them a quality toilet, people are ready to accept.
Chandra, for you, I will say why I asked those two questions is this. Because anytime you get any fund, donor or CSR, or even worse, when it is a program funded by the government, you only get funds for the capital cost of creating any such thing. You never get a fund for maintenance. You did, offer some idea of what you do. For example, when you say that you also help the community understand that they should not use Harpic and such synthetic stuff, it means that you have somebody on the ground who is as committed as you are in a way that he or she is able to communicate with the community and enhance the quality of what they secure for themselves. Is that right, Chandra?
If they are not aware, we have to make them aware. See, the point is the repeated usage of these chemicals and stuff like that. Invariably, these are all mostly agrarian lands in the village areas where I am focusing for want of lack of toilets. So we have to tell them very clearly what is going to be the least costing maintenance. So when we talk about neem oil or anything, vinegar, you can just soak any leftover lemon or anything, soak in water and create vinegar, natural vinegar sort of. So it is an enzymatic reaction, right? So when we tell them, they listen with awe, and later when they practice, they come to know these costs are zero almost. So that way we have to educate. Even if there is nobody there, the best pick is the local unemployed graduate or somebody who can understand to a level of what could be the long-standing effect of these type of applications.
Yeah, for the
Yeah.
benefit of the others here, can you explain how you have managed to do that? Because in every village, if you have to have someone, like Susan said earlier, who will monitor, that becomes impossible for you, Chandra, if you are only reliant.
I'm not the government. Wherever I have an opportunity, I do it. That's a very small level. I say in a nano level. But
I
if
got
like
that. Even
Niranjan said, suppose we have to have sessions in colleges or in villages through the self-help groups or anything, we can convert this into a video lecture or anything or a demo lecture in various vernacular languages and spread it across to the people. So I can help on those type of thought process. If somebody is ready to collaborate, we can do videos or things in various languages and put it across. Yeah.
Chandrasekharan, one of the challenges in the toilet domain is that the cleaning work, etc., is given to the so-called lowest caste, and the upper caste doesn't want to do this. So how are you going to handle this challenge, which is a challenge across the country?
As long as the places where we have installed, caste is not a problem, sir. Money is a problem. They are all people with less money, mostly daily wages or agrarian laborers. So for them, getting a clean toilet for their women folk and their girl child itself is a big challenge. So no caste comes in between when poverty is the biggest killer. Okay, I have not seen this as a huge problem. In fact, they are very conscious about their women and girl child going safe into a toilet. So they take in turns. Actually, what we do, we have a system like if at all there is a caste system, few toilets only they will allocate, they have a key and lock and key. Another set of caste that you cannot avoid. Another set of people will have another 2-3 toilets with a lock and key. Within themselves, they will plan what to do and how to go about. That is the only way. We can't go deep into their ecosystem because that will kill your time and my time as well. So,
Chandra, what you just told me is education for me, and it's music to my ears, because this is one challenge I've seen in the north. So maybe this challenge is not there in the south. Okay, thank you.
when poverty strikes, caste doesn't come in between at all.
Yes, well, the change management issues are significant, as we all know, in water and wastewater and getting people to adapt new practices. And Hari, I'm curious, based on what you have done with the WOW group across the major urban areas, moving out to the multi-unit buildings, what suggestions would you have for Susan on just at a high level anticipating India? And is this something that would have appeal in your mind?
Well, thank you again, Mary, for asking. Susan, I'll put it like this to you, both to you and Chandra. Both of you are working at the end of pipe, right? You're working on what you can do with used water.
Mm-hmm.
And you are trying to see how, health and hygiene is more the priority than availability of water or the reuse of water in a certain sense. And I'm not being, you will forgive me for making a generalization, shall we say. Now, India, if you look at a country like this one, we have no more than 1.2 million liters as per capita water availability. Alarming. And if you go by UN standards, any standards in the world, doesn't matter which organization, the moment you reach 0.8 million liters, which has never been reached by any country, by the way, in the world, you are at a not just a crisis, you are at a level of alarm when it comes to water. India has today 0.4 million as consumption per capita, as against this 1.2 million liter availability. China, for example, has got 2 million, although they are at about 6 times our GDP. That is, they have ravaged their country over 20 years, with this incredible economic surge, and yet they have 2 million liters per capita availability. Your country, the United States, has got something like 18 million liters. Canada has got 30 million liters, to give you a perspective on who has got how much. So for us here, as Mary has been very appreciative of, we need to look at start of pipe in a country like ours. If I take this city that you will be visiting next month, we are about 700 square kilometers. which means we are 70,000 hectares of land. Now, if I have 1 hectare, just 1 hectare, and we have rainwater falling on it, that's 10 million liters, right? This means that Bangalore, if it were to cleverly, intelligently harvest all its water and make use of it, the rainwater, it will reduce some, it will possibly jeopardize some natural linkages for water. However, it will be able to meet nearly 80% of its water requirement without long distance water, all the challenges of energy and carbon that cities like ours suffer. And this is not just one Bangalore story. So to my mind, after listening to both of you, start-of pipe solutions have to be taken out and not merely let that water recharge some aquifer. We have to utilize them. We have to ensure that we are using that as drinking grade water. We are not doing that. There is not a single water consulting professional in the country I know of who does anything like this to take rainwater and make it drinking grade water. Thank you, Mary. I'll stop there.
Yeah, Hari, could you also just expand on the wastewater treatment within the schools that you're doing at some of the RainReach programs, yeah. I believe.
Yeah, well, Ravalji is the expert. He's the one who has who's guiding that. You see, it's like this for all of you. If I take a school with, say, 1,000 kids, and if I were to assume, say, 15 liters per capita, we have about 15,000 liters on a day. We have only typically 200 working days for a school in 360 days. If I were to take this 15,000 liters, and if I were to create a constructed wetland, which is, analog to a natural process, and Dr. Raval knows these things much better, all we need to create is about 5 m cubed, 5,000 liter capacity, volume-wise, for every 1,000 liters. So if you work the peak demand for a school between, let's say, I would say about 12 to about 3 for 4 hours, and then see how much you need to create as a wetlands capacity, which is only digging civil works. We dig a bit, we create this volume, put a few baffles, put a set of species, about 6 to 7 species, and we have discussed this on this same Wow Action Forum a few times in the past. I have some pictures and such things to show another day. What then happens is we do not use energy-based systems like Chandra was saying for water purification. You heard him, 500,000 households he's managed. That's 2 million people who are getting, without your RO process, without any of those marketed products in the country. Similarly here, we do a zero energy process for wastewater treatment. And that water has no odor. It can be reused for landscape and such things. You can't drink that water, but it's good, to be using that water. And the cost of doing it is not so formidable that we cannot afford to put it in a school. Over to you, Mary.
Yeah, that's beautiful. I think what we're doing also in the United States, there's a whole movement with the water reuse organization and the processing of waste, turning it into water, nutrients, and energy is a beautiful thing, and not toxifying it, as Ravalji noted, with Chandra's approach and that approach that you're using in the schools. So that's part of the intersection of how we manage toilets, but this disconnecting from the pipe to distributed systems is also something that's being done by a group called Hydroloop that I should have invited to join this call. They're taking all the gray water and reusing it on site, and you can look them up at hydroloop.com. But I do have a few other people from different parts of the world that I'd like to have chime in on this conversation. And Festus Langit is here from Kenya, and he is observing the needs in Nairobi slums and also in the villages in Africa. And Festus, could you comment on the application of these technologies to your area there in Bomet County, Kenya?
Thank you very much. So I'm saying here in Kenya, the problems that we have is divided into two. We have a rural setup, and those in town. And I see the approach that have been explained by Susan and Chandras as very important, even in slums in town, because we have some slums in Bomet and in also a lot of slums in Nairobi, and we'll need that technology for that in Nairobi. I wish if one day they can be invited to Nairobi to teach us, or we can have some sessions or to learn from them. It's really very important. So places like Nairobi slums, they are very, very congested, densely populated, and obviously water is a real problem in those areas. And that's when where I see that we really need that approach in Nairobi.
You would need the hand-built units, not the monitoring
Yes.
technology, correct? Yes, yes.
Indeed, yes.
Right. And I know that Jacob Kabenga, also in the community around in Nairobi, has identified a few slums and provided pictures of them where the need is really great and very obvious. So
if I may add for Festus, I'm very glad he brought up this about their, you know, I've been to two of their large settlements. One is, I think, called Kibera, Festus. The other is called Mukuru. Yes. I went to Mukuru, must have been about 4 years ago, right? It's appalling, the conditions there. In fact, we must have had about 6 or 7 community meetings over 3 days. And we told them of things that they can do there for just ensuring that their sanitation waterways are cleaned up. Very simple, no capital cost, only some OPEX cost kind of solutions we offered them. But they couldn't come back. I think it's the same challenge as Chandra has. Like Chandra was right. He is an innovator. You don't expect him to also go and convince people and get monies and get funding and such. I think that was the sort of situation I saw in Mukuru, at least. I think you have about 250,000 people who reside in Mukuru alone, right?
Yes.
Go ahead, Rafalji. Thank you.
Meetings breed meetings. Water cannot be studied in isolation. We have to take a composite view. Coming to schools that I visited with Hariji, that was nearly 3 years ago. But schools are a source of nutrients. Most of the 98% of students, they use urinal. They don't use the WC. So the defecation is not the major part of the school sanitation area. And urine is far more bigger a source of nutrients than fecal matter any day, anywhere on this planet. You see, let us understand what we are discussing. The budget will come. People are ready to fund and support any good cause. Niranjanji, we need not ask Mary to fund anything from anywhere. The whole world is there to support anywhere, any good cause. The point is, it's time we get started with the concept. And concept dialogue does not require funding. It is the implementation that needs funding. And domestic is a very small component of the entire water picture. Thank you.
Yeah, that is a beautiful comment, and isolating the urinal treatment or the water capture in some way and processing of that so that we can get the phosphorus and all those nutrients out is a wonderful idea.
And urine itself is an RO product. The whole world is, drumming on reverse osmosis and all that. What is urine?
Yeah.
It's the product of kidneys, which is fundamentally a nature's reverse osmosis plant. We mix it with the fecal mass and make the whole exercise far more difficult and costlier, and above all dangerous. And we are talking about GDP and economy. We are increasing the budget for digging the grave and then talk about saving economy. That's never going to help us. Thank you.
Yes, that isolation and the distributed systems are key points to remember. And we have an individual here in the group who is an expert in permaculture. And Jay, I'm wondering if you might comment on just this treatment of the urine and the human waste, if you're able to unmute. And I will bring it up because I think you wanted to offer a solution to everyone for consideration.
Yes. Hello, Mary. Can you hear me now?
Hello. Yes,
Hi.
and thank you for
Yeah.
joining us from the UK. I'm bringing up
That's
your
okay.
your picture here.
Okay.
Can everyone see this?
Yeah, I've been actively applying permaculture principles for about 35 years now, since reading Bill Mollison's fantastic book, Permaculture Designer's Manual. My original career was microbiology within the the conventional wastewater treatment system, so using engineering approaches. I then went through a little stage of doing reed beds, and then I now do tree bogs, which are compost toilets, which directly turn the compost into tree biomass without having to handle it or bucket it anywhere. I do wet systems, which are wetland ecosystem treatment systems, which are soil-based constructed wetlands, which integrate wastewater purification, biomass resource production, and habitat creation. And I also do water retentive landscapes, and all of these things have been mentioned in this session. But what I was particularly keen on finding out is about the tree bog, which it's a novel way of composting in place, in situ toilet wastes, both urine and feces, and turning those into tree biomass. In Africa, for example, we put some in Kenya, in a refugee camp. In terms of funding, I would love to get some funding to create 37,500 double tree bogs and have one of these in every compound, which, apart from addressing open defecation, pit latrines overflowing, not being emptied, creating disease, as well as one of the chaps mentioned earlier about the dangers of young children, girls and women going to public latrines. If there was a tree bog in every compound, a family compound or a groups which knew each other, then that would be obviated too. So I just would really like to get from this group their views or fears or whatever they think about the tree bog. Just to put in context, I've used a tree bog in my own off-grid existence now for 40 years. So that's in the, I know they work.
Wow, Jay, how interesting. And I throw it open to others in the group. Rivalji, you want to comment, since this is clearly the biological approach to things, and have you observed or tried out something similar? And you're muted. Yeah, there you go.
This is the answer. Jankin has written a book on human, and he's a world authority. And Dr. Peter Morgan advocated this in 1960s and 70s while working in African countries. He's a UK physician, spent more than 50 years in African countries. And this is the solution for human waste management. Pipe and water is something that we want to see our tiles clean. That's not the demand of the sewage. Thank you.
Yes, thank you.
Yeah,
I
in
appreciate
fact, Mary, I want to just say there is something called eco-sand toilets in India, practiced by very few environment conscious people. There are actually two bins, Indian latrine, the flat one, not the Western toilet. And below there is a huge, actually 1 meter by 1 meter cubicle, where the fecal material is going down and is covered with ash or sand or straw or whatever, sawdust or anything, which is a biodegradable material. And the bacteria in it will try to eat away and decompose the material. So when the pit is full, they close that one toilet and then the second pit is open. So people use it for next 15 days. So below the 1 meter cubicle, there's a trap by which they just pull out the decomposed material which has been converted into a biological manure with no smell, nothing. And that manure looks very fine, dust, dark brown color. That is used as a natural fertilizer for the plants around. A very easy method, no need of any STP or anything like that. This has been very much used in some of the environmental conscious NGOs in some of the toilets we have built. Thank you.
Yeah. Well, Jay, thank you. I think you put the presentation into the community or into the chat here. We'll upload it to our Global Waterworks community as well, and other people can follow your template. But you mentioned the cost, so and fundraising for this. What does a unit like this cost? It looks like primarily labor and local materials. So could you speak to what your estimate is based on the ones you've developed?
Yes, I could, Susan. In Kamiak village, we were given a grant of $2,500 from the Realliance people. That paid for me to go over there, materials and the trees, and providing food and people's accommodation for the length of the build, which was 3 days, 4 days. So that was in 2019, $2,500 for everything. I didn't go to the refugee camp in Kakuma. I did this through Zoom meetings, and the cost of providing 35 people with a tree bog workshop over the course of 2-3 days, where we built one, was it was $2,000 in total, and that provided food and accommodation, transport within the camp for these 35 people. So the actual materials, probably depending on what's available, and most of the materials in Kakuma had to be bought from Nairobi at huge cost. So I would say, depending on what materials available, between $1,000 or less, really. If you can use those panels from the windmills, you've got that there. We're looking at using bits of old car, especially in areas where there are termites, where wooden structures might be destroyed by the termites. And although the termites could be viewed as a problem, actually they really help the compost be broken down. They take the compost into the soil, feed it to some fungi that go underground, and then use the fruiting bodies of the fungi as their food. They're actually acting as earthworms would in the UK in a very hot environment where earthworms can't survive. So we look at everything with permaculture. A view is a positive. We can look at things, and even if they're negative, oh, the termites are eating the wooden structures. So we say, okay, but the termites are also helping the composting process and recycling those nutrients to the trees. Just as a matter of interest, some of the tree bogs in Kakuma were built just before a very long drought, 2-year drought, and the trees that survived were moringa and neem, both very, very hardy trees and both incredibly useful, both medicinally and nutritionally. But on top of that, in subtropical, tropical environments, we can grow mangoes, papayas, bananas, as I said, moringa, citrus. So they're all useful trees and can become part of a home garden. And if I can just drop this before I take up any more time, we are really hoping, our vision for Kakuma Refugee Camp is to convert what is a desert through tree bogs, through utilizing the water which is brought in at great expense, instead of it being tanked out as sewage from pit latrines, use it to create a food forest. Each double tree bog in Kakuma can be surrounded by between 15 and 20 useful, economically viable fruit and nut trees or timber trees or firewood trees. And we would love somehow to provide 37,500 tree bogs, one in each compound, and transform that area of desert into a food forest, and probably change the local weather conditions at the same time, the local climate. So that's the vision. We've got 10 in at the moment so far. Another 37,490 to go. So thank you very much.
Yeah, congratulations. I think this is the type of innovation that we all long to see, where nature actually serves itself right alongside the water capture with the rainwater you're showing in your tree bog. You add the phosphorus and nutrients, and as Ravalji said, perfect. So if people do want to fund, Global Waterworks is a charity, as is the All Tech Foundation, and we would be happy to partner on solutions like this to get you out or to hook you up through Zoom, as you say, Jay, and help organizations. So Festus with his outreach in Africa and others, if you have interest or solutions, I'm including Jay's email here, and then I'll add our Global Waterworks and All Tech Foundation addresses. So please, if you have a question, have an idea you'd like to share, raise your hand or use the hand raise feature or drop it in the chat. We want to make sure everyone who wants to comment has the chance to do so as we have time.
He has given us the secret of sewage treatment. You see, we have bacteria, a lot of bacteria in the column, discharge along with the excrement, and it is the soil which have the fungi, and none of them are capable of doing the job in isolation. This is a genetic evolution which took place nearly 500 million years ago. Sometime later we'll talk about that. The point is, different situation, different septic tanks, different STPs, different organs of sewage management have different environmental pressure situations. And no microbe is entitled to do the job for eternity. Depending on the environmental pressure, there is an exchange of DNA material between fungi and bacteria, which create a suitable species to do the job under variable conditions. And what we find successful here may not be working somewhere else. So yes, any standardization of a sewage treatment plant working world over is the, I mean, illiterate self of our sewage understanding. Thank you.
Yeah. Thank you, Ravalji. And I know we had folks, Malcolm Fabii, with I'm going to put his name in the chat. He was also addressing the waste management, and we all enjoyed his discussion on the microbiomes that can come in. And he runs a company called Optima Biome, and let me add that. But I welcome. We have Rojit, I want to say, is here, who is working in Ohio and has some pretty incredible waste treatment systems. And he may have left. Rakesh, I'm sorry, Rakesh Govind, are you still available? And might you chime in on the status of your systems there in Ohio and the water reuse activities here in the US?
Sure, yeah. Basically, what we are trying to do is develop a more advanced system that can treat nutrients and wastewater, basically sewage, in a very cost-effective manner. And one of the problems we're looking at is that most of the energy for water treatment, wastewater treatment across the globe is going in aeration, because dissolved oxygen is the limiting factor. If you want to do aerobic treatment, you have to put dissolved oxygen. So we are trying to essentially create nanobubbles. We have a technology that can create nanobubbles of air, and the advantage is that we can create a very high surface area and very high oxygen transfer efficiency. So we can go from a 6% oxygen transfer efficiency that is normal in aeration right now across the globe to almost 80% because the bubble size is very small. And these bubbles, nanobubbles, less than 1 micron, they do not combine. They do not coalesce into bigger bubbles. So they stay in the water for hours and they give oxygen as they traverse the water medium in this case. So it's a very effective solution that can reduce the energy of aeration in wastewater treatment by a huge factor. And in some situations, we are using essentially 95% oxygen instead of air, and that can shrink the size of the wastewater treatment plant, especially for decentralized treatment. It can shrink the size of a community system to a much smaller and a much more cost-effective solution because we have reduced the energy of aeration by using nanobubbles, and we are using pure oxygen, 97%, 95% oxygen instead of air, so that increases the concentration of oxygen by a factor of 4 almost. So we can shrink the size tremendously down. So that is one of the advantages that we are incurring by doing treatment on-site, decentralized systems using this more effective technology in this case. So that's one of the innovations that we are bringing in the decentralized level of sewage treatment.
Yes, with your next gen septic presentation, I know it's beautiful. I'm putting that into the chat if people want to look further at that. And I included your LinkedIn address, Rakesh. Thank you for joining us from overseas. When you think about toilets and what they'll look like in 2030 and beyond, does everyone have them? Are they distributed? Just 2 to 3 sentences on what our septic and sanitation looks like in your mind.
I think the technologies, there will be many different types of technologies. Some are indigenous, some are requirements that they don't require water. They're composting type of systems. So I think that there is no one solution that fits the entire globe. The economic conditions are different, the population conditions, the land availability. So basically, each nation or each country has its own methodology and solution to handle the sewage. But in the end, water scarcity is a global issue, and we need to be able to recycle the water back. So that the whole idea is that eventually any sanitation solution needs to be able to create water that is brought back for reuse, and of course also bring rainwater for reuse and to drinking water. So that's something that we are now trying to achieve. Like in Texas, we are installing systems that can bring sewage water into drinking water. So essentially it is DPR, direct potable reuse, and that is allowed in Texas, and now it's California as well. So that is something that we can achieve, just not rainwater, but also sewage water, bringing it back to the drinking level standard.
Dr. Adil, can I quickly ask you to respond to what Rakesh presented on nanotechnology and the future of wastewater treatment?
It will be better if we have everybody on the screen so that can we have now that you see the chief objection that I have is the term aerobic should be clearly understood. And in my view, it has not been understood so far, world over. Because first 2.3 billion years of the age of planet, there was no atmospheric O2. And atmospheric O2 is not oxygen. I make a statement that atmosphere has no oxygen. You can challenge me and we'll have a debate on it. Coming back to my first part, we are 4.5 billion year old as a planet. We have atmospheric O2 since 2.3 billion years. Before that, there was no O2 in the environment. Does it mean there were no aerobes? And if there were aerobic organisms, what were they? Atmospheric oxygen is merely a convenient term that we use O2 as oxygen, which is not. O2 is a dioxygen, chemically speaking. And it is a reject of a living cell. Plants throw it out as a gaseous excreta. Plants also have cellular digestion. C6H12O6 plus O2 is equal to H2O CO2. Why do they throw out that oxygen if it is O2 as required? So aerobic term does not connect with O2, number one. The question is then, what is aerobic? I had requested Hariji for a session on aerobic and anaerobic. That's it. At the most, facultative. No engineering textbook covers this part of the topic that we are discussing now. Aerobic is a building process. And the first ever aerobic reaction that appeared on the planet was CO2 plus H2O, where oxygen came from CO2. CO2 was a carbon donor as well as oxygen donor. There was no O2. So let us understand the chemistry, the science, and what we are talking. Otherwise, marketing gimmicks, there are plenty of that. And still everybody is facing problems. Highest number of death during pandemic happened in the countries which are developed. They are rich. If their money could solve the problem, why did they die? So we have to have an overall view of the whole thing we are talking. And unless we have our science basics sound, which Hariji is not in favor of, he says we have no time to go into the science of that. And that's something I don't think we'll ever reach the shore. Thank you.
I am from a non-profit organization working in Odisha in India. And we have been last 30 years of experience in working with community, rural and tribal communities on the theme of housing and sanitation. And what exactly from Swachh Bharat Abhiyan in India, what we found that first is the geo-NGO coordination is very weak and becoming more weak. And there is a lack of communitarian approach in addressing this issue. Toilets are made maybe half a kilometer away from the houses. They are all wastage of money, not used, no provision of water done by the contractors and other things. So there are certain bottlenecks to it. If it is communitarian approach, if it is planned properly, if there is a provision of water, if the provision of energy, light, because most of the women, children, disabled, they need safety, and it should be nearer to the houses. It is not urban area. I am not talking about urban area, but the rural tribal areas. They need all these things. So it has to be planned meticulously and using the money, mobilizing from different sources and educating the community for that. So those aspects are lacking in our flagship programs. That is why it is failing measurably. So that is the practitioner's view is like this. So I am a very
well said.
Communitarian approach. I always try to put, and thank you for asking me to give my opinion.
Thank you, Mr. Chaudhary. Very, very well said. Gopalji, very quickly, any word from you? I'm stepping over the time space.
I think some fundamentals may have to be rethought through. Swachh Bharat is a huge investment, but that's not the way I look at it. The honest part is it's the women who wanted the toilet. If you think money can drive this world, I think you're living in a different world. It is the demand, and that's the change that is happening. And so it is that which should require the focus. Otherwise, we'll get very funding focused, project focused, coordination focused, etc. It's the people's aspiration that we have to deliver. That's my first submission. I think, I have a little problem in my head. We see world in silos, we address it in silos, and we see the problem. And then we come up with a universally golden view. Even there, I have a problem. I think somewhere that thing has to have stepping stones that you address, deepen, fight the silos, and then move towards it. That roadmap is unclear. Thank you.
Thank you, everyone. Was there a last chance to chime in? I guess Hari noted we're ready to close now. We've taken 90 minutes of your time, but it's felt like a brief glimpse into a bunch of friends, a bunch of collaborators who we know can support this initiative to move what the number 2 man has done for 27 years in raising awareness, getting World Toilet Day on the map. You all have been advancing in your own individual areas. And my recommendation is that we advance it together, break down the silos, share ideas like this tree blog. Who would know that before today's call, and get the stuff done. So everyone has access to a toilet and sanitation and the beautiful fresh water from above that you are making happen with RainReach and with these individual efforts and with treatment, Chandra. So thank you all. We are indebted to you because you are the ones who make global water work.